Good morning! So glad to be here today. Here's a quick story. 7 years ago, approximately, I gave my customer a bad advice. Now, these things can happen, only this time it ended with a production issue, an embarrassing one. What's happened there? I was sitting in front of the CTO, which asked me a question. We have this, a message queue, an R code, and how should exactly test this? We have the internals of our code, the business logic and all the internals, and the message queue client libraries. Now, what should we test here? Should it be a unit test, integration, end-to-end? What exactly? Now, frankly, I had no idea back then, and I did not have enough confidence to admit that, so I started to think and running many thoughts in my head what they should do, maybe unit test of only the internals, maybe the entire thing end-to-end, what exactly? They were looking at me and waiting for answer, and I'm running a lot of thoughts in my head. Then I had to make a decision, which was last minute. Okay, you should test the internals, I think, because why bother with all the messy message queue words? Let's just isolate the words and get ourselves great testing perks. Now, guess what? It works. It worked then. All the messages were flying from the queue to the internals, and everything was great for a week. Because after a week, we start seeing poisoned messages, messages with different schema, with invalid schema, that was triggering the code to fail, to throw an exception, which was good, because the code should have thrown an exception. What should have happened is that the message queue wrapper should have just catch this specific message and reject it back to the queue. However, due to some bug, it didn't catch granularly every message, rather the entire failure, so it rejected back the entire batch of messages. All of the messages, even those who were processed already, were rejected. Then the app entered a poisoned loop, while the message queue was keep serving again and again the batch of messages, including the poisoned one, and every time reject all of them together. Bottom line, 20% of the system messages were not processed. Day later, the CTO looked into my eyes and say not even one word. And I learned 2 lessons. The first one is that testing things in isolation inspire less confidence. Anytime you uncover some layers, so avoid checking some integration, it's a bug, it's a door opening for a bug. The second lesson was that I should learn more about this topic. So I typed in YouTube, in Udemy, about testing message queues, and I got absolutely 0 results. In Amazon, searching for a book got the search engine completely crazy. So the first result was about an home router and some webinar in Italy. So crazy that the search result was a massage oil. Amazon completely was unfamiliar with this type of searches. So I went into this journey alone of finding what are the right message queue testing patterns. The natural next move would be, if testing in isolation failed, maybe I should test with a real message queue. So I went this way and started with approach of not mocking everything. Test the real thing, the real message queue. And what I found out is that it's not a walk in the park. For a start, I saw testing stealing messages from each other. So test 1 puts its blue messages, test 2 puts the gray one, and what's happening in test runtime was that each one was stealing messages. Now I hear you thinking, oh, you should have cleaned up between tests, right? It's also not an easy task with real message queues, because trying to purge a queue will clean up the queue for a second, but then other messages in transit might land a second later in that queue. In SQS, for example, going by their documentation, you need 60 seconds, 1 minute for a purge operation. So I tried. So lesson 2 was that testing with real message queue is not easy. It's a flaky monster. Not unlike database. When you test with database, separating between tests is much easier. You can separate by the records. Each test acts on its own records, and you get full separation. Eventually, I tried 2 approaches and both failed. I think that we can frame most testing mistakes on this diagram. You're either going too blue or too red. Blue means the galaxy of developer experience, when we see comfort and speed and determinism. And the red word is about our will to test as much as production as possible, to catch bugs early. So what I tried first, an isolated code, was too naive and missed bugs. The second approach was too noisy. What we really want is that sweet spot in the middle. And this is the goal of my talk today, finding with you the sweet spot of getting both developer experience and also realistic tests. Before I start, a few words about myself. I'm a backend consultant. I'm doing workshop and consultation for organization, which allows me to do the things that I really love, which is blogging and writing. I wrote a few JavaScript guides. And all the examples that I'm going to show you today, you can find in my new repo, Node.js Integration Test Best Practices. But I didn't create it alone. 2 of my friends and colleagues were working with me in the last 2 weeks. 10 p.m., we had a WhatsApp group. We were exchanging ideas. So many thanks to Daniel and Raz for contributing so much to this talk. OK, so let's start discussing solutions. Recap, what was wrong? Isolated tests do not inspire confidence. Real message queue is flaky. Also, when we're doing message queue tests, many times there are timers and polling and nasty patterns. How can we do better? So when I'm looking into this diagram, based on my experience and research, the sweet spot there in the middle is a fake message queue and the recorder pattern. Let me show you. First, this is the system under test. We have the user component, belongs to other team, which publish a user-deleted message. Then it goes to RabbitMQ, but anything I show here is quite agnostic to any message queue. And we, the order component, consume these messages and delete the corresponding orders. For a start, we need to code an object, a class, a fake message queue. Basically, it's an in-memory message queue implementation, super simple one that will be used mostly only for testing. Now, it has all the typical functions that any message queue has, like publish, consume, acknowledge, reject. And if at this stage you're a little bit worried, I can understand. We don't want to maintain our own message queue, our own code, and start maintaining it. And so no worries, it's going to be super simplistic. In fact, under 30 lines of code, you're going to have a super convenient fake message queue for testing. Let's see. For a start, for the first function, you don't even need to implement anything. Just throw an event. That's it. Let the world know that something happened. One line. For 2 functions, you do need to implement something very simplistic. Consume, we get a callback, a function that we need to call once there is a new message. All we do is we store it locally. That's it. Then, in the publish function, where a new message is being shared, we check, is there a callback, a consumer that is waiting for messages? If yes, just call it. And always throw an event. We will see soon why. Now, on top of this is the fake message queue. This is all you need. 17 lines of code. On top of this, you need the recorder patterns. What is the idea? We want to store everything that happened in the message queue so we can expose it to the test. So basically, we just create an object for every type of event that happens in message queues, and we start the counter to 0. Then, for every event, we can iterate over the provider, in our case, the fake provider, and anytime the event happens, we increment the counter and the data of this event. That's it so far. In overall, 29 lines of code. So how does this serve us in the test? Let's see. This is a test example. when we want to test. When a user deleted message arrive from the user microservice, we are the order microservice. We want to delete all the corresponding orders. So we start by defining an order and adding it to the system. Important pattern, each test creates its own state. We don't rely on anybody else. So we added the orders that should be deleted. Now we start the message queue client. And we pass in the constructor the fake provider. We can control which one. We can also provide the real one, so we can reuse the same test for a fake or a real. And then, next step, initialize the system under test. What does our code do? It's queue subscriber. It grabs messages from the queue and processes them, tries to delete orders. Setup is done. Now we can start acting on the system. What should happen? We publish a message to the user deletion queue and hope that the code that will do its job. Now assertion. However, I want to assert that indeed the order was deleted, but how can I know when to do it? I have no clue when this operation will end. When I'm testing API, I just approach the API, get a response, and I know that everything is done. With message queue, it's more challenging. And this is where many developers fall into a trap. They start using timers, pollers, callbacks, and this is flaky and slow. Instead, just use a promise. We are already recording all the events. Expose this using a promise and let the test await for a specific event. You saw in the keynote how easy it is today with JavaScript to transform events into a promise. So basically, what the tests say, hey, let me know the code. When you are acknowledging the message, in SQS it's deleting it, then I know that you're done. And now I can assert and approach the API, try to get the deleted order, and ensure that it's not there, it's 404. And you can reuse this pattern for any type of message queue interaction that you can imagine, like check for publishing messages, rejection, deletions. And you can use it to check almost all the message queue scenarios, like poisoned message. Some message with invalid schema is causing our code to crash into a loop of serving it again and again, or a zombie process, where our message queue is not even able to start and the process stays alive like a zombie. Or message duplication, unordered messages, rejection. If you want a full checklist of what should be tested in backend, including message queue, you have the slides, click here. I have this post online. However, there are something that cannot be tested with a fake. Things like retry and dead letter queue, where we need someone, the message queue on the other side of the line, getting messages and orchestrating them, replaying them back, moving them to another queue. In this case, we need a real message queue. There's no escape for this for some testing. So when I'm saying testing with real message queue, I don't mean anything in production or in the cloud. Every reputable message queue product has a local Docker that is good enough for testing. And you have a full list of examples here. Just use a local Docker. But didn't I say that it's very flaky to use a real one and test our deleting messages from each other? Yes, but we can tame this beast if we're doing one thing. If we're creating a dedicated queue and topic per test, we can remove most of the flakiness of testing with real message queue. Let's see a test example. What I want to test here, and I can test only with a real message queue, is that when a message keeps failing again and again, eventually the message queue is sending it to the dead letter queue. It's a special queue for failed messages. On the right side, you have a visualization of what's happening in the test. So for a start, we initialize the message queue client, this time with real RabbitMQ or SQS or what you're using. Then we have to use mocking and tell some function, hey, keep failing, because I want to simulate failure. Next step, we need to create queues, both a regular queue and a dead letter queue. This helper will randomize and add a timestamp to the queue name, so each test gets its own queue. So you can see on the right side now, a queue was created and a dead letter queue. Next step, what we want to assert on is that a message arrived to the dead letter queue. So our test is now subscribing and listening to the dead letter queue. Setup is done. We are ready to put a message in the queue and see whether all the pieces are playing nicely together. So we publish user deleted message. And the code is now waiting for the consumption of a message from the dead letter queue. First part, the queue sending the message to the code. Will the code succeed? Obviously not. Yeah, because this mock that instructed it to always fail. So failure, we send back the message to the queue. What the queue is doing? Usually replaying it back again. So the queue is sending again the message to the code, which keeps failing and failing again and again and again. The message is now again in the queue until we reach the maximum retries. Now the queue is desperate and tells, okay, there's no escape from putting it in the dead letter queue. Since the test is consuming the dead letter queue, it will now finally, the assertion will get satisfied. Because we were waiting for a message in the queue, we were waiting for this flow to be completed. And indeed, we get everything works and we get this workflow checked. My main point here, it's maybe one of the most complicated message queue flows, and we get it working in flat test, 6 statements. Not because of any rocket science or dragon spitting fire magic in the box. Simple patterns. Mostly these 2 ones that are marked. Create a dedicated queue for test and create a promisified interface over all the message queue events. Looks like my clicker is not working. Let's try to get closer. Okay, I'll play it from here. So, bottom line, we have fake and we have real. Which one should we use? I would frame fake in this sweet spot there in the middle. It's my primary technique for testing message queues. In a real message queue, I would put it somewhere there in the noisy red word. Why I love fake so much? Because it ticks most of the boxes. No flakiness, super fast, natural flow. We just put messages in queue. We let the real component work with database, with almost everything. It can support multi-process. It covers most of the risk. And then I would use real message queue, mostly for the wrapper, the message queue library, and for microservices where you need very high confidence. So everything worked on my machine, but there is one spectrum of issues and potential bugs that we didn't cover. See, by now, all the messages are, for now, I'm also the consumer and the publisher. All the messages that we are interacting are based on the belief of what we think should be the schema. But then, in production, we meet a new friend, the publisher. Now, the publisher believes that the schema should be like this, without the field B. However, we think that the schema should include the field B. And then only in production we realize this mismatch and fail. And consider many integration, many versions, many schemas. It's very hard to miss this line of bugs. And this is called the contract problem. And I'm going to show you 3.5 ways of dealing with this type of issues, with the contract issue. The first one, the most simplistic one, is documentation. There is now an emerging spec for documenting message queue. It is called async API, very similar to OpenAPI and Swagger, same syntax, only you can document also the channels and the queue names. So it might spare you from some bugs, but obviously it's not enough in a world of so many versions and complexity. Option 2 is PACT. PACT is a very reputable framework in the testing world. And if you're familiar with PACT for APIs, this is a little bit different. It's PACT for message queue. Now, the idea is that someone should generate schemas, declare what schemas is needed. And very surprisingly, it's the consumer who declares the schema. Now, once it declares all the JSON schemas it is expecting for, it is sending them to the broker. A broker is kind of a web app in the cloud or in your machine that saves all the schemas. Then the publisher is reading all of this schema and ensuring that it is compatible with this schema. And finally, updating the broker. It will become much more clearer with code. So what we have here is a consumer test with PACT. We want to ensure that when a user deleted message arrives, the schema is well formed. Then we call PACT and tells it and instruct it, hey, for this message type, we expect this content, this schema, these fields, also with an example value. I was expecting something more standard, like JSON schema, but no, it's PACT proprietary format. Then PACT will invoke the consumer handler, the consumer code, with the defined schema. So at least the consumer can guarantee that it is conform to its own schemas. Under the hood, what's happening, PACT is creating JSON files, and at some point in your workflow, for example in CI, you need to run this command, this CLI, maybe from your CI, and send all of these files to the broker. In return, the broker will give you this beautiful and helpful UI that shows you for every integration what is the status. So you can see, for example, did the provider verify these proposed schemas? Now, I'm the consumer. Can I deploy now to production? I have new code, new proposed schema. Can I put it in production? Obviously, no. The provider didn't even verify. So what the provider should do here? Again, a test using PACT framework. This is the publisher side. And after declaring its name, we have to define the broker URL. Why? Because this is where the expectation, the consumer schemas exist. This is what we need to check against. And then we need to declare what we, the publisher, will produce. What is the... So we declare the message type, user deleted. And now, here we should tell PACT what messages we will produce. Now, I was expecting here something a little bit fancy from PACT. Hey, invoke my code and realize which messages I generated, maybe approach my queue. But no, PACT is taking a very Unity approach. It just asks for a simple function, factory constructor, that tells, hey, this is what the publisher knows to produce. Then it compares the expectation and the reality. If they match, automatically, under the hood, the broker is now updated. And as a consumer, I can get a webhook, I can see a Slack message. Oh, great, my code works with the provider. But can I deploy to production now? What do you think? I don't know if this verification is already on the provider production. And this is what's interesting about the contract problem. It's not only about comparing schemas, it's also about knowing which version is now in production. And PACT has a very rich framework for this. I'm going to skip most of the parts due to time limits. I'll just say that it gives you tools in your CI to just update which version is now in production. You just call PACT and tell, hey, I just deployed version 1. So eventually, the consumer gets this super helpful and powerful command. As a consumer, in my CI, I can now invoke this command and ask, hey, can I deploy as the user service version now to production? PACT will look in its own records and check, let's see, the provider version in production is this. Does it work with this consumer version? It will do the match, and if not, CI will fail. So PACT is great at covering all the workflow. This is number 2. Number 3, which I'm going to cover in 10 seconds, is schema registry. It's part of the most modern message queues like Kafka and PubSub. And it's very rich and interesting. It can also do runtime validation, but because it's not supported in half of the message queue provider, I'm going to just remind it, just follow it. I think it's going to be one of the strongest option in the next following years. Option 4, which I like a lot, is NPM. How can NPM serve us as a contact mechanism? Let's see. The idea is simple. I'm the publisher. I have types. I can expose them in a package, in NPM. Then as the consumer, I can import this package and then get all the benefits, strong types, and contract verification. Let's see with code. So this is the publisher code. And I need to delete my message, interface, schema, object, something, JS doc, whatever you like, with all the fields. One very important observation, I'm not doing it for the consumer or for contract. Anyway, I have this part of my code, right? So it's, if I have some issue here or mismatch, I will realize it in my own test. And on top of it, let's assume that I want to deprecate this field. Deletion reason, I don't need this field anymore, so for a start, I just deprecate it. Optionally, you can also export a validator function, something that gets the message and doing some validation over this message for yourself, but we will see very soon that it will be very helpful for the consumer. Next step, I'm just publishing into NPM, and now we have an NPM package with all the types and the validator. I can go even one step further and add tags to this package here and mark whether it's production compatible. So each version, I'm going to soon provide a lot of packages and a lot of versions, and I can mark which one is now supported in my production. And I can also mark deprecated fields. So as the consumer, I can read and see, is the versions that I'm using now production compatible? Great. Next step, now I'm the consumer and I'm going to get 3 benefits. The first one is IntelliSense. For a start, I import the NPM package. What you see here is JS doc syntax for importing a type. If you're using TypeScript, of course, it's just import. And now I want to publish a message. So here, it's not longer custom JSON where it's very error prone. Rather, I'm getting full IntelliSense from the message that comes from the publisher. Second benefit, runtime validation. This is my consume function. The consume function is invoking some handler, passing a message. But now it's not longer a custom JSON, rather a typed message. And I'm using the publisher validator to fail, to check the message, and I'll fail very soon. So it's super powerful. Both the publisher and the consumer are using the same function and types. Also, they are not connected. It's not end-to-end test. And when I'm saying failing fast, in runtime, it's test time. The consumer will fail during testing. Now, at some point, the publisher wants to get rid of this field completely, so it's deprecating the package. As a consumer, when I'm trying to install, I'll get a warning. I can make my CI fail when I try to install deprecated fields. Then, okay, I'm not sure what changed. I didn't read the docs. I just update the package, and what I get in return immediately, my test will fail. My consumer test is going to fail because this field was deleted. I just discovered contract mismatch with the provider with very natural NPM flow. So which one I would use? PACT, NPM? Again, this diagram. I would say that PACT should rely here on the red side, less developer experience. Although it's very powerful and rich, I would suspect that the flow would not be natural to most teams. So use it for microservices that are really challenging, mostly on the social aspect. And NPM contracts, sweet spot. I mean, they don't have all the features, but you get your familiar workflow and syntax. And in overall, if I try to summarize all the techniques, I would put also fake MQ as the sweet spot there in the middle that will get you covered for most of the things. And once you need a little bit more confidence in a specific scenario, you have more techniques, a little bit less developer experience, but more realistic. And in overall, I think that the art of modern testing is finding the sweet spot there in the middle. Thank you very much.